Okay, if you moved on to a different proof, I need you to go back to number 1 and go over number 1 with me, because I need you to make sure you get this 100% correct. If it's wrong, I need you to fix it. I'm not going to rewrite my givens because I'm feeling lazy right now. Given. Okay. You are told that you have stuff segments bisecting each other. So you're going to use the definition of a segment bisector. We know that for sure. You have several things congruent because they're bisecting each other. Abby Chambers, can you give me one set of things that's congruent? Okay, so QM and TM. It looks like an O. And you should mark that in your picture. Logan, what else? XMRM. Mark it in your picture. So that's the other big thing with these proofs. You need to mark it as you go. That way, when you're done getting all the congruent pieces, you can look at it and very clearly see which theorem you're going to use. There's a freebie from the picture. Kyle, what is it? Just by looking at the picture, what else can you get congruent? Yep, these two. And a lot of us have this marked, and you're like, 1's congruent to 2. I don't know what 1 and 2 are because you haven't labeled it. So if you're going to do that, you have to write in 1 and 2. Now you can say 1's congruent to 2 because of why? Vertical angles. I almost said alternate interior, which would be wrong. Vertical angles, look at your picture. If you're not sure which theorem you're using, mark in little letters for your congruent pieces so you can tell. Matt, what are we going to use? Number 1, which theorem do we use? SAS, side, angle, side, because the angle is between the two sides. And ASS doesn't work and it's inappropriate. Okay. So make sure you say, yeah, they're congruent because of side, angle, side. Okay, very good. Number 2, I'm not going to write in the givens again because hopefully you did that already. Okay. Number 2, you are told that you have, oh wait, freeze. You are told things in your givens. Please make sure you mark those in your picture. You have parallel lines, and you also know actually that those two sides are congruent. Mark both things. You want to see everything that's going on. Because you have parallel lines. Allison, you have parallel lines. What should you immediately say? Or what do you want to use? I'll come back. You can have 2 sets if you want. You do not need both of them, but you can use both of them. You could do these 2 and those 2. If you're going to use both, then make sure you mark them differently. So angle 1 is congruent to angle 2, and you could also say that 3 is congruent to 4. Both of those because of alternate interior angles. Yeah. Angles. So if you want to use those as well, you can. Make sure you mark them. You don't have to do that because you already had 2 angles. So that's like optional, but it's not going to hurt you to say it. Because of vertical angles. That's a freebie. Okay, now look at your picture. You actually have 2 options. Because you have all 3 angles. Let's mark in what we have congruent. You have all 3 angles and you have this side. I would just mark that so I can see what's happening. Ava, what's one option for how I could prove the congruent? What's one theorem I could use? Yep. Angle, angle, side. With these 2 in that side, or these 2 in that side, and then you have another option. Addie, Roush, what else could I do? ASA. ASA. You can do either one. Doesn't matter. Okay. I'm going to write that down. Make sure you have a proof that's correct. And then work on number 3. 5 minutes. Ready, go. NML. You could do AAS or ASA. Go to number 3. If you're not on number 3, please flip there. You are told that you have AC bisecting angle BAD. You're also told that BA is congruent to DA. You need to mark that in your picture right now, that BA is congruent to DA, so you can see it. When you're told that you have an angle bisector, look at your cheat sheet. It says that you should say you have angles congruent, the two angles it splits apart, because of the definition of an angle bisector. So if you want to say that these are 1 and 2, you have to label them 1 and 2. Those two angles are congruent because AC splits up that top angle in half. So in your proof, you should say that 1's congruent to 2 if that's what you're calling them, or you can use the letters. Because of definition of, you need to say an angle bisector. That's what we were given, is something that splits an angle in half, so it has to be an angle bisector. Right now you have a side, you have an angle. You need one more piece, because you always need 3 things. What is the other piece I could get? Ethan, what else could I get? Just by looking at the picture. Yep, you have a reflexive side. AC, congruent to AC. It's a shared side, so you say reflexive. And now look at your picture. You have which theorem? Side angle side. Good. Do the next one. 5 minutes. Go. SAS. You are told that 1 is congruent to 2. You should go ahead and mark that right away, that they are congruent, so you can see it. You're told that B is the midpoint of DC. So, John, since it's the midpoint, which 2 pieces are congruent?
DB and BC.
Yes, DB and BC, or CB, I guess we should say. DB is congruent to CB because, Cole, what's the reason for that one? Can you put your phone on? Why are they congruent?
Segment bisecting.
Close. You have a midpoint, so what should we say?
Definition.
Definition of a midpoint. Good. You've marked that in your picture. Ava, how can I get another side? On number 4?
DB is congruent to BC because of segment bisecting.
We have those. We need one more side.
Oh, AB.
Yep, your shared side. AB to AB. What is the reason for that? I've done this several times. Cole and Joe, can I have your phone away? Reflexive. And then you need to look at your picture. You have side, angle, side. Okay, if you've not done the last one, I need you to do the last one. SAS. Do the last proof. So if you could have number 5 out in front of you on the green paper. On your givens, you're told that you have perpendicular lines. You're also told that you have an angle bisector. So let's start with the angle bisector. AB bisects this top angle here. So that means it's splitting up that top angle into 2 pieces that are congruent. So you can say 1's congruent to 2 if you label those because of the definition of an angle bisector. Please make sure you have this out because a lot of us missed a step on this one. This is a trick. If you have perpendicular lines, then you should say that you have right angles. That's all you can say to start off with. So these 2 angles at the bottom, you can label them and write down that they're right angles. Check your proof right now. that you have angle 3 and angle 4, or whatever you labeled them, are right angles because of the definition of perpendicular. This is a part I need you to make sure that you have because a lot of us miss this step. They're right angles. They are congruent because of right angles congruence theorem. So because they're right angles, you have to take another step to say that they're the same. So to say they're congruent, you have to use right angles congruence theorem, which says that all right angles are the same. And then you do have a freebie from the picture. What is it? Reflexive. You have a shared side. So you can mark that and write it down, that AB is congruent to AB because it's reflexive. Looking at your picture now, you should use angle, side, angle. Okay. So please make sure that you have a step in there to say that the angles are congruent because of right angles congruence theorem. It's not on your cheat sheet, but it is on your cheat sheet that you can only say the right angles and then you take an extra step. Okay. Please make sure you scan this. If you don't have time tonight, you could do it tomorrow in class. Bye. Put this blue stuff in the back.